In this video, we'll take a look at the Cisco DECT multi-cell AirSync considerations if you're running into problems or if you're getting ready for deployment items of consideration. If we look at the documentation provided for the DBS-210, as far as the actual signal strength for the AirSync, they suggest negative 75 dBm or lower. The screenshot I have below is an example which I'll show in a few moments from my lab, where one of the base stations, DBS-210s, went into search mode or searching mode, meaning it has lost clock sync. And one of the items we want to take a look at is there something in the environment that was introduced that was causing increased levels of attenuation? And this is really critical during the site survey and early pre-deployment stages to determine the attenuation levels between the base stations, what variations may be seen over time. It is recommended to do some testing with at least 2 base stations or more over a period of time, especially if it's a venue such as a warehouse, airport, or other venue where the items as far as attenuation, packages, pallets, number of people, etc., trucks, may vary the attenuation quite a bit. There also could be other sources in environment that are increasing the noise floor. Thus, even though the numbers may look good, so let's say you're in the low 70s, you still may run into issues with multi-cell AirSync. As a starting point, it's recommended to have approximately 20% overlap between the base stations in a multi-cell DBS-210 type of deployment. And ideally, we would have multiple connection points between the different base stations. In this example, the edge base station on the left top corner has 2 connections, 1 and the number 2. And then the mid base stations here have 1, 2, 3 connections. The material that is in environment can play a big role as far as the distances one has to consider from attenuation standpoint that can be achieved. So on the top here, some items that are listed as low would be wood, plastics, so doors, floors, and so on, room partitions. Then mid would be tinted glass, living objects, and bricks. Ceramics and concrete would be listed as high. Tiles, walls, pillars, floors, stairs. And then very high would be metal, elevators, and cabinet. If you're working in an environment that is maybe dealing with custom type of material, bespoke material, defense industry, aerospace, you definitely want to do testing. There's certain types of material that is very high in absorption when it comes to RF energy. And this would be an example of a front office on the left-hand side here, where there's less objects as far as between the base stations. So here we're achieving 2 connections on the front base stations towards the front of the office here, where less usage of DECT phones may be needed. And then here towards the back we have 2 connections again towards the front base station and side base station. And then between the front office and the warehouse, we're assuming there's a window right here. And then this has line of sight, and we're assuming this is a 2-story building. If this is a 1-story building, and especially if there's trucks here, they may be parking or other objects, shipping containers, this would definitely be an issue. So this assumption is a 2-story building. We have a window here in the front office, a window in the warehouse, And we have multiple points of connections from the front office to the actual warehouse, just in case one of these connections has an issue with attenuation or some type of other issue. We don't lose connectivity from the front office towards a warehouse and vice versa. And then once we get to the warehouse, there's going to be assumption that the shelving in here in the middle may be really high up, and thus we can only make line of sight connection if the warehouse has a very dense material, concrete, brick, liquid, salt, baking soda, etc., etc. Those materials typically RF energy, because the density of the material is not something it can really propagate through. So in this case, we'll just make sure we have line of sight. So from the front of the warehouse towards the middle of the warehouse, and then towards the back of the warehouse, the energy, the RF energy can be propagated. And likewise, we have kind of going here towards the middle of the warehouse. And then from there, it kind of can propagate as needed. So if you notice, we're kind of doing a semi-mesh here, so we don't have one point of failure. You would obviously want to evaluate what coverage needs to happen in the warehouse. Do aisles in the middle also have to have coverage all the way through? And this is where additional base stations may need to be considered. These base stations don't have removable antennas. They are omnidirectional, so there is no option, as you may be accustomed to, like with Wi-Fi, to do directional patch antennas or Yagi antennas, or if you're doing super long distances like a parabolic dish. So just be aware, the antennas are actually built in. They're not detachable. They are omnidirectional. For North America, this is using 1920 to 1930 megahertz. It is a frequency specifically allocated for these DECT devices for communication usage. And as far as multiple stories, you do want to be careful. Generally speaking, in a lot of buildings, the floor will be some type of metal with also trusses and possibly also concrete, depending on the actual structure. And normally the propagation will be very limited. In some cases, no propagation may be possible. There may be conduit, piping, HVAC, ducts, condensers. Also, depending if any of the walls or firewalls, they need to be rated. It could be a situation that propagation may be very limited. You may need to do a base station spread out equally through each floor. Here, there's assumption there is some propagation. If you notice, they're staggering this base station towards the edge, this one towards the middle, kind of in a zigzag, and then this one again towards the right-hand side, and this one towards the very bottom edge. So this is during the site survey where you definitely want to evaluate what the situation is, but you want to make sure you have enough headroom. Because if you're testing it during non-working hours where there's no people, no merchandise, or whatever may be normally placed there, then the numbers you're seeing may be very misleading. And this is where trouble can be occurring in future once it gets deployed and the attenuation levels are too high and the signal strength is not enough for the clock sync to occur. Okay, so these are some possible values when you're troubleshooting that you may see. So one of the things I'm going to show is a searching example. I also may show some other examples. We'll see what we see in my lab. I'm going to do some heavy attenuation. The space I have my two base stations in is not very large, so the only way to generate a symptom is I'm going to have to use some metal boxes and additional material to attenuate. These devices, believe it or not, are really difficult to attenuate if you don't have a large space. But in any case, so these are the possibilities of different type of listings you may see on the actual admin page. A footnote, if this is deployed with WebEx Calling, you do not have admin access. If you are having issues, you want to open up a case with Cisco TAC, and part of the process, they're going to ask you a number of different questions in effort that a temp admin password can be created. So they'll be very critical, because without a temp admin password, basically a lot of this stuff I'm talking about really is not going to be possible. Specifically, you know, the different items we're going to look at within the actual web interface of the base stations. So normally, under good operating circumstances, we'll have a unit that's selected as the primary for the clock synchronization over there. Also, I may refer to it as RF clock sync. Then the other units will be locked. So this will be good. So this is like normal operation. Everything is A-OK, and this is what we should normally see. If there's something that is causing attenuation, then you most likely are going to see searching. The base station is trying to synchronize with primary base station. Also, you may see free running. The base station has lost its synchronization with the primary base station. Unknown. There is no connection information. And this is more rare, this assisted lock. The base station can sync with the primary base station using DECT, and that it is using Ethernet to sync. And then there's sync lost, indicates that the base station has lost synchronization, but there is an active call on an associated handset. When the call completes, the base station will attempt to synchronize. Okay, so let's continue here. Okay, so this is going to give us some additional information about free running. So this is definitely one of the states you may see listed if you're having issues with portions of your multi-cell not functioning correctly for the DECT handset. So free running state is when a base station has not synchronized its data from the sync source after a period of time. When this happens, the base station will change to a new state after 2 minutes. So one thing to note is the refresh cycles and the state changes on the base stations are not the quickest thing, so patience is critical, especially sometimes if you make an adjustment and you realize your signal strength is not strong enough and you go place the base station to a closer, better position. You may need to wait, 10, 15, or even maybe more minutes, depending on the size and other variables that are going on. So it is a process that is not going to be very quick, so patience is a key component when troubleshooting multi-cell. If the base station is idle, the state changes to searching. If the base station is on active call, state changes to sync lost. When a call completes, the status changes to searching. Reasons for free running state can include there are two bases using the same DECT slots and cannot see each other. There are many simultaneous voice or data calls, so this would be if there's a really high dense deployment situation. There was a sudden change in environment, for example, a fire door close, or if you're on a ship or some other environment where the doors, the walls are either metal or a combination of concrete and metal. So that's where one item I will mention during this video is there is a Plan B option. It is not offered on WebEx Calling at the time of recording this video, and there are some special considerations. It's called a LAN sync, IEEE 1588, also known as PTPv2, so be aware that there's another method of doing. Typically, it is not recommended as the first consideration because there's other potential pitfalls, but there is another option which I'll mention a few times during this video. There was distortion of the DECT frequency, so be aware in the United States it would be 1920 to 1930 megahertz. I think here they meant 1.8 gigahertz for international usage. So I believe this is a typo. This should be gigahertz, and 1.8 they do use in other countries. So the 1920 to 1930 megahertz for US sometimes may be referred to as 1.9 gigahertz. So I think this is just a typo. This is actually sourced. Be aware a lot of these are sourced directly from the admin guide. I have a URL listed at the bottom, and or the deployment guide, which on some of the other pages I make some references to. Okay, so base station goes into free running state. Okay, so change in the DECT slots. There are a number of different slots that the DECT units use, almost, if you will, similar to the concept of channels in Wi-Fi. This may be enabled the base station to connect to a synchronized source. Just as a footnote, the frequency used by DECT base stations is totally different compared to Wi-Fi or Bluetooth devices, so that is a real big benefit. And since it's a lower frequency on the RF spectrum, when compared to Wi-Fi, it does have a much better opportunity as far as distances that can reach and also opportunity of propagating through different materials. It is still going to be limited if you run in certain materials, steel, concrete, etc., but in most cases you will see noticeable performance benefits versus equivalent Wi-Fi equipment at 2.45 gigahertz. Change the state to assisted lock. This is where it tries to kind of use a LAN to synchronize. This enables base station to use information from the other base station. So yeah, in a rare occasion you may see it going to this assisted lock, and we'll see, based upon testing I do in a lab, what results we see here in a little bit. If an assisted lock state is stable for a long time, you can change a state back to locked. The free running state may also change back to locked. Okay, and that is true. You do have to be patient when troubleshooting multi-cell issues. It is something, the larger the deployment, the longer and the slower things take to change. So just be aware. And what I suggest is, if you're having issues, if you can boil it down to one switch, meaning if you cannot make heads or tail what part is broken, if possible, let's boil it down to one switch and two base stations. Can we get stability? If we can get stability, let's bring up a third base station on a adjacent switch. Can we get stability? If we take a step backwards and we have two base stations on one switch, we cannot get stability. Let's take it down to one base station and one switch. Can we get stability? If we still can't get stability at that point of time with that base station, we'd want to consider factory defaulting it. If this is deployed on WebEx Calling, as soon as you factory default the base station, it will pull down a configuration from the cloud as far as what it needs to register to the cloud. Be aware, most likely you will need to re-register the handset to the base station. It's just how DECT works. So you want to take baby steps. Typically, you don't have to take everything down to one base station from a troubleshooting standpoint. If it's only one or two base stations are having trouble, you may want to temporarily take them offline, doing a shutdown on a switch port. And then once everything stabilizes, you can try to bring that up using no shutdown command on the switch port and figure out what is going on. See, we have set up a multi-cell, but the multi-cell web page shows searching in the DECT property column that calls base station can't communicate. I showed this, I think, initially on the very beginning. This is what is suggested in the admin guide as far as the negative dBm levels for the signal strength between the base stations for multi-cell clock sync. We definitely want to be very careful. It is stated here we want to make sure we're negative 75 dBm or lower is recommended. Keep in mind, in most environments, the attenuation levels do change and sometimes can change quite a bit. That's one vector point. The second one is the noise floor level. Unfortunately, that's not something you'll be able to really see or measure unless you have spectrum analyzer and or other tools that are able to act like a spectrum analyzer. And there could be harmonics being introduced if you're near some towers or other equipment that's working on another frequency, but the equipment's very strong, the output's very strong, and it's having a harmonic that's being produced, and it just happens to be falling on the band that DECT is using. That's another possibility. You always want to see how much headroom you can have. If you're not sure about your environment as far as the dBm swings, are we talking about swings of 5 dBm? Are we talking of swings of 10 dBm? Are we talking swings of 15 dBm? 20 dBm? This is where this can be very misleading. You can say, well, we can push it all the way up to negative 86 to negative 90, but how do you know what level of swings you may see in your environment when it comes to the dBm attenuation? So this is where my suggestion, definitely, once you start hitting negative 70 dBm, unless you're absolutely sure you know what level of dBm swings you may have over time and over different situations in our environment, it's very dangerous to start inching yourself upwards here. So this is where you may need to do a evaluation on the site to understand on some of the links that are critical links where maybe you're trying to interconnect two buildings and you don't really have much choice. What happens between those two buildings? Are there big trucks that come in? Is there shipping containers where they may be stacked multiple stories high? That may in itself just cause a blockade or something else that might be occurring. So that's very critical, because this is where I think often folks may get themselves into kind of a trap. And then this kind of causes a lot of other issues they see throughout the DECT multicell to kind of occur. Let's see, there's something interfering with the radio signal, kind of we talked about. There may be a door equipment disrupts the radio communication. Okay, you may need to move the base station. When you look at RF, and this again is not only DECT, but it pretty much applies to any RF technology. It's very similar if you ever have worked with audio. Either it can be a PA system, it can be home stereo system, it could be a stadium. There could be quite a big difference positioning the base station, sometimes just moving a base station a few feet, also adjusting the direction of the base station, even though the antenna is omnidirectional, can play a big role. So these are all things in the pre-sale stage during the site survey. Using ladders, preferably making sure the ladders are of fiberglass, so the metal, non-metallic ladders, fiberglass would be best. And keeping the base station away from any I-beams or any other metallic objects, because that can have a big influence on performance of the base stations. Okay, so let's go down here. Okay, so let's go to the next page. These base stations are not NEMA rated. They're for indoor usage only. So that's where you have to be very careful. The temperature range is 32 Fahrenheit up to 113 Fahrenheit, 0 Celsius up to 45 Celsius. So there are areas where these numbers may not be good enough. Nevada, Arizona in the summertime of the continent, 115, 120, 125, sometimes we'll have week-long days where that's kind of a common number they're hitting. You go on top building, towards the top portion of building, unless there's active HVAC, you can get temperatures much, much higher than that. So be aware, this can affect things. Also, if you're going up north, Canada, Alaska, Minnesota, any of those states, for good parts of the year, they're going to be below 0 C or below 32 Fahrenheit. So be aware this can affect it. The reason I mention this is if you're to put this on a roof inside a closure, the closure would have to have active cooling and also active heating. Also, you would need to make considerations for a lightning arrestor or a lightning rod. So just be aware this is not designed to go outdoors. If you decide to go in that direction, these are some considerations. There's also humidity considerations, 10 to 9% non-condensing. And then let me see if there's anything else. The units themselves are actually very small. So height, width, depth, and weight. The units are very, very lightweight. It makes them very easy to mount in many different areas. As far as mounting, I would say just keep in mind, if you in the future you have to service the unit, if there's any troubleshooting or anything else you need to do, if possible, try to position it where it's not going to be very difficult to get to the unit. I know in some areas that may not be possible. It may be going really high up on a ceiling where the ceilings may be multi-story just because of the size of the structure, airport, large storage facility. large storefront, etc., but just kind of keep that in mind and document exactly where it's at. Take photos, so if a couple years down the road somebody else has to come by and do any maintenance, it's not too difficult. Okay, we'll take a quick look at the results I was getting in the lab. The item I'm showing here is I ended up accelerating the speed about 1,000 times. This was tested or taken over a 2-day period over many hours. So in effort to show you a lot of information in a relatively short amount of time, I'm just speeding up all the different things I've captured during my testing. And if you notice, I'm refreshing the screen for multi-cell. Bottom right corner, we're showing the different levels of negative dBm signal strength we're getting for the clock sync. And right now it's fluctuating. It's in the 70s. A moment ago 79, now 73. These are obviously negative numbers. And that's where I made a comment earlier. We need to be very careful on what, okay, so we're in the mid 70s now, how much actual changes we're seeing in the environment as far as the signal strength for the RF clock sync or over-the-air clock sync, if you will. So I am attenuating both of the base stations. I have them in steel boxes in 2 different rooms. I have a limited space where I'm testing this with, and there was really no other way for me to generate this attenuation. Okay, so it just went into searching mode. So it just hit a level of threshold where it lost the signal, or the signal was not good enough, and now it is gone in searching mode. So you'll notice we show searching in the bottom left. Every so often you'll see a red, that one of the units is in a red state. So in this example, I only have 2 units, 2 DBS-210s. If you have a much larger deployment, obviously what you're going to see is a much longer list of items. But you'll notice it's still in searching mode. And I'm just going to, okay, bottom left corner, if you notice, it's showing there a red status for the device with a warning message. And it's still showing under DECT property searching. So I'm just going to let this run like this for a period of time to see if it's able to reconnect or not. But I was mentioning I've had to go to extra steps to cause this unit or both of these units to go in this type of mode. So normally in a smaller structure, this has quite a long reach. So unless there's metal, there's concrete, one of the high materials as far as attenuation rates. Okay, so it just got locked. So it's showing a lock state right now with a negative 79. Also, the numbers can be relatively tricky. You'll see in my example the numbers jumping all over the place, even though the only change you'll see is going to be perhaps me walking in and out of the room. There are no trucks, there are nothing else in the space I'm testing. I did over time need to add additional attenuation materials to cause the unit to go into a search mode or one of the other issue modes, if you will. But other than that, there's no other changes that visually I'm seeing in the environment. As far as is there any influences from neighboring locations, buildings, etc., that is a possibility. I have done quite a lot of spectrum sweeps for a good amount of time, and the only thing that I found is really GSM 1900, but I did not detect any type of leakage into the 1920 to 1930 megahertz RF spectrum from GSM. Is it possible there's a random harmonic at times it pops up that I'm simply not detecting? That is always possible, but in general terms, nothing so far I've detected. So right now we're at a negative, so we're jumping negative 75, negative 77 dBm. We are showing a lock status. And this is why doing testing on site, evaluating to see what, okay, we just jumped up to negative. So the higher the negative the number, the weaker the signal. This is why physically testing this at the site to understand under different times of the day, perhaps different days of the week. If it is a shipping yard and there's different type of shipping containers, different type of materials, are they shipping in heavy machinery? Is it maybe sugar, salt, different types of containers with different fluid, etc., etc. All of these are going to have different types of effects on the attenuation rates. So again, the numbers are jumping. They're generally in the negative 70s, low 70s, mid 70s, high 70s. And when I'm doing this testing, as I mentioned, it's really the only change perhaps is at times I may leave the room and come back in the room, but that is it. Everything else is really static. There's no heavy machinery locally. I just have two computers that I'm typically working off of, a PC and a notebook, and that's basically it. Obviously, there's a few small switches I have, but there's really nothing from a noise or RFI or EMI generating device, if you will, in the vicinity that I'm aware of. But yeah, we're seeing quite a lot of jumps that are occurring here in the actual signal strength. And this is why the site survey and you performing your own analysis is really critical, so you can, okay, just jump up to negative 84 there for a moment. So the higher the number, the weaker the signal. And this is a logarithmic number as far as those values go. So this is why it's very critical to do a thorough evaluation, especially if it's a larger deployment in a complex type of environment. If it is a airport, stadium, large-scale warehousing, shipping yard, hospitals can be also very tricky. Anything that's very dynamic as far as the quantity of variables that can be introduced and also the type. Okay, so now we dropped onto negative 69, meaning the signal just got better or stronger, if you will. So we've seen some really big swings here, all the way up into the 80s down to the high 90s. So that, again, that's quite a large swing of values since this is a logarithmic scale. Okay, so we'll see here. So what I end up doing at some point of time is I do add some additional items to cause an increased level of attenuation to basically cause it not to be able to function over the air sync or the RF clock sync, if you will. And then we'll take a look at option B, which is not really offered on WebEx Calling, if this is being run on WebEx Calling, if you will. But it is something to consider if you've determined that the AirSync method of synchronization between the base stations for multi-cell is not doable and you've exhausted everything. You definitely would want to open up a TAC case and consult with a WebEx Calling backend team, and obviously you'd also want to get the DECT phone team involved and see, is it feasible in your situation to consider PTP v2 or what they call Lansing, IEEE 1588. There are special considerations from a switching infrastructure standpoint because the timing for PTP v2 applications tends to be very, very tight. So latency, jitter, and packet loss are some of the key items of concern. And also, obviously, to make sure the propagation of the PTP v2 packets is successful between all of the base stations for the clock synchronization. So that is an option B, but as I mentioned at the time of the recording of this video, it is not offered on WebEx Calling. It would have to be really kind of a one-off evaluation to see if it's something that makes sense. If you're deploying this with another platform, CUCM or another generic SIP platform, if you will, then that's something you would be able to evaluate on your own. And I would keep things very basic. Start off with just two base stations, one switch, and go ahead, and I'll show here in a few moments once we get this into a state where it has an issue regarding the clock sync, the air clock sync. But in any case, start off very basic, one switch, two base stations, and run the IEEE 1588 LAN sync, if you will, PTP-v2. And you do need to make sure that QoS for EF marked packets, expedited forwarding, those packets are put in the highest priority, strict priority queuing, so they get processed the quickest. And then run it for a period of time. If you go, at least run it for a few hours. Do a bunch of test calls where you're roaming between the two base stations. Try to have the two base stations separate apart as much as possible, so you can force the actual roaming to occur. And then you do want to introduce at least a second switch or more, depending on your situation. And if you have a third base station, you want to put the third base station on a second switch. You only have two base stations, then move one of the base stations from switch 1 to switch 2. And then make sure the communication between the two switches, as far as PTP-v2, and the two base stations, as far as the clock synchronization and also the roaming, if you're going from one base station to another, all of that is functioning correctly. The amount of switch hops that you may have that this needs to traverse is another key element of consideration. So that is something that you definitely want to evaluate. One area that can be very misleading is if you're testing this and there's not a load on the network, it can appear that everything's working correctly if you're doing the LAN clock sync. So you definitely want to either create an artificial load or make sure you do testing during a peak period that the network will normally observe during operational hours. So let's see here in a few moments. Hopefully we get to the stage of, so it just went to -69, so the signal became stronger. And then we'll see in a few moments when we get here. And this is, so -84 now, so this is really where I mentioned the swings that you may see on the actual signal strength can be quite large jumps. And especially if it is a situation, there's a lot of new items being delivered via trucks, the pallets and the shipping containers may be changing on a constant basis based upon the environment this is going to be positioned. So the amount of signal strength possible can vary quite a bit. It is always best to try to achieve a line of sight, as I mentioned. So if you have this going between two buildings, you'd want to make sure that this is positioned in a window on both sides if possible. And then also it is not going to be, it won't have any type of objects in the way, so it's a line of sight. So those would be optimal. There could be certain types of windows that have quite high attenuation, so that's another thing you want to evaluate to see what attenuation, depending on the tinting on the windows, and if they're double windows or single windows based upon the climate that this is being positioned in. So generally it's in the mid-70s, and every so often we'll get some outliers. They may jump into the 80s, and also some outliers, they may jump down to the negative high 60s. And this is a logarithmic scale, so those types of changes are actually very large as far as energy goes. The one thing really also could be the floor noise level, in the environment, could also be causing potential challenges, because even though you're outputting a certain level of energy, if the signal to noise ratio is changing to a level where it is not functional, meaning the noise is increased but yet the signal is where it's at, and it's like walking into a room that's very noisy and you're trying to talk to somebody next to you, you're going to have to increase your volume or get close to them for them to understand what you're saying. So this will kind of have the same effect. That's very interesting. It just hit a negative 115. That's very odd. Okay, it just took a nosedive there. It went into free running, then it had assisted lock, then it recovered. Okay, it's gone back to free running. Okay, so it looks like right now it's definitely lock assisted. Okay, so it's definitely running into problems with a few moments there with the air's clock sync. But in any case, if the floor noise or the signal to noise ratio is changing, meaning it's shrinking, we don't have as much headroom compared to the floor noise, that in itself could be an issue. The other thing also could be the materials could be causing different type of reflections. Generally, the radios of most modern equipment does have additional logic to be able to try to correct or use different antenna elements. The data sheets and the admin guides and other material that I've looked at so far has not published or has not offered regarding detailed technical information of radio or antennas as far as if it has diversity and any other type of, from an algorithm standpoint, what mechanisms and what logic he uses to determine if there's issues with a clock, over-the-air clock sync or air sync, if you will, how it determines what are the next steps in trying to correct those issues. So those are still kind of a question mark, and that's why really I'm kind of showing you what I've seen when I was doing testing over a 2-day period over many hours. Again, this is being sped up 1,000 times, so that's why you're seeing a lot of these refreshes. It's me clicking and then waiting for a period, clicking and waiting for a period. This process does go very, very slow if you're troubleshooting, so be aware. It is, okay, so went into free running and it's showing the last recorded value was negative 90 dBms. Okay, now it's searching. Has an infinity sign by the dBm, if you notice. So right now, as far as it's concerned, there is no signal strength for it to pull off of or for it to lock onto for the clock sync. So it's still in searching mode. If we've exhausted our approaches of being able to correct it, and option B is IEEE 1588, kind of what I'm showing here. You would not be able to do this from the base station. If this is on WebEx Calling, you would need to open up a case with Cisco DECT and discuss this option. But if you notice, there's the multicast group for PTP v2, there's UDP port 319, there's domain number 0, and there's alternate domain number 64. I'm going to simply hit save here. We also do need to make sure on whatever other units we have, we kind of repeat the process. So we're going to go to LAN sync on our second unit, repeat the process, and then we're going to go ahead and also save here in a few moments. Some of the settings may get propagated. If this is on WebEx Calling, you would not be doing this yourself. This is something, as I mentioned earlier, you would open up a Cisco DECT case and you would have a discussion, and you would actually have quite a lot of stuff on the networks inside you would have to look at. Is QoS configured on all the switches? Do the switches have updated firmware? Is there any concerns as far as latency, jitter, packet loss? How many switch hops are we looking at? Do any of these switch interfaces show any statistical issues? Packet loss, CRC errors, runs, giants, etc., etc. Once the PTP v2 stabilizes and things look good, go ahead and do some test calls, go ahead and do some roaming test calls, and then you want to apply a load on the network. You can use iPerf with a couple of notebook computers, and I would first do some 5-minute test runs to see how things perform. You want to put the notebooks on opposite sides of the network so the load is going to be placed on interfaces that the PTP v2 and or VoIP packets need to traverse across the network. Typically, we're going to see issues if QoS is not done correctly or there's other limitations of the switch platform regarding firmware, ASICs, etc. It's on the interfaces that interconnect the switches. And what will happen is once you put enough load where there's congestion, that's where QoS really needs to go ahead and do its job to protect high priority queuing traffic from lower priority traffic. So really you want to go ahead and do some test runs, maybe start with 5-minute test runs, go ahead and increase that if that all looks good to 20-minute or half an hour, go ahead and increase that maybe to an hour. iPerf you can do up to 24-hour test runs at a time. So you may want to do a couple 24-hour test runs if possible, maybe start it on Friday evening and then let it run over the weekend until Saturday if that's your maintenance window. You just want to get evidence that everything is solid even under load when using PTP v2 or LAN sync. What happens when we first bring up PTP v2, there's going to be a election that occurs for the PTP v2 Grandmaster clock, and that's kind of what is happening right on the background. I only have 2 units here, so generally it shouldn't take too long for the clock PTP v2 Grandmaster clock election to complete. Okay, it looks like it's completed. We have primary and we have lock status. Okay, great. Okay, so if you notice the infinity sign instead of the actual dBm value, because now we're using the LAN for the PTP v2. And then we'll take a look at the statistics it gives us. So you notice a lot of the statistics are listed in nanoseconds. They're under status, offset, 63, and then those 8,748 nanoseconds or 8,748 nanoseconds, 11,906 nanoseconds delay. And then that's the multicast group for PTP v2 we're using. So everything looks like it's logged in and functioning. Hopefully this video has helped you. Thank you.